So today we're going to be looking at a problem where and we're going to go through the 4 problem-solving steps. Okay, so the first step of Polya's problem-solving set is to read the problem and find out what I'm looking for. So it says in here, it is to find the area of the triangle GHJ to the nearest 10th. Okay, well obviously we have triangle GHJ right here. Okay, GHJ is right here, and we have to find out what they're asking us to find. Well, what we're asked to find is the area, okay, and what are our unknowns that we have, or what are our knowns? So for this triangle, we have a known leg of 10 centimeters, another known leg of 7 centimeters, and an angle of 108 degrees. Okay? So we should devise some sort of plan to solve for this. Now, assuming that we don't know any other algorithm or that we don't know any way of doing it, we're looking at this problem for the first time. The first thing we're going to do is we're going to think about what do we know about triangles. Okay, so I know that the area of a triangle, the formula that we use all the time, is 1/2 base times height. Okay, so we know that it's 1/2 base times height for any triangle. Okay, B being the base, H being the height. Now in this one, okay, our height would be outside. Okay, so it would be right here. This is going to be the height of our triangle. And the base would be actually extended out a little bit more. It would be 10 plus this unknown B right here. And so what my plan to do is, my plan that I'm going to devise, is I'm going to find that value of H right here. I'm going to find the rest of the B for base. And then I'll find the area of the whole thing. Okay, so then we're actually finding the area of a triangle that looks like this. It's a right triangle. And after I do that, then what I'm going to do is I'm going to take this little piece that I added on, that I found, and I'm going to subtract the area of this whole thing, right here, to be left with the area of the triangle GHJ that they're asking for. So since this is H, this is J down here, and this is G, okay, I can find the area of this part right here if I find the area of the whole right triangle, okay, and then I subtract out the part that I added on. Okay, so that's my plan, and so we're going to go through with that. That's our third step, is to just go through the plan. Okay, so what I'm going to do is I'm first going to find the value of H right here. Okay, so to do that, I have this right triangle that's formed right here. It's a right triangle. And and I know this angle right here. Now, how would I find that angle? Well, I know that all straight angles add up to 180 degrees. And so this theta is going to equal 180, is going to be 108 plus my value of theta right here. So if I subtract 108, I find that my theta is 72 degrees. Okay, so now this is 72 degrees right here. Okay? And so if I know that, what I can do next is use my trig ratios that I know that I'm very fluent in, my trig ratios, to find the value of H. So, since I'm looking at this theta, I'm looking at the opposite side over. The nice thing is I have this hypotenuse, which is 7 centimeters. So what I'm going to do is I'm going to find what the sine of 72 degrees is equal to the opposite side, which we're calling H, over the hypotenuse of 7. And so I solved that for H by multiplying by 7. And 7 sine 72 degrees is going to be approximately, now they tell me to round to the nearest tenth, so I'm going to do that, 6.7 centimeters. Okay? 6.7 centimeters for this H. Okay, so now we know our H, right? Okay, so right here, this is going to be 6.7 centimeters. Okay? Then, now we have to find the area of our base. Now, we know that this portion of the base right here is 10. But what we don't know is this portion right here. And again, we're very fluent in our trig ratios. And so from that theta, that angle, that 72 degrees that we found, that's going to be the adjacent side over the hypotenuse, which in our case is going to be a cosine. So it'll be cosine of 72 degrees is equal to the adjacent side, this little b, over 7. Again, I solve it the same way. Okay, and I find that this little b, 7 cosine of 72 degrees, is going to be 2.2. Okay, and again, I use it on my calculator and I find that this is going to be 2.2. So this little guy right here is going to be 2.2 centimeters. Okay, so then my base itself, my whole base, would be 10 and 2.2 together. So this is going to be 12.2 centimeters. And so the area of this big triangle that I've created, okay, the big area of that is going to be 1/2 times 12.2 centimeters times 6.7 centimeters is going to be, so this is going to be 40.87 centimeters squared. Now that's the area of the whole big thing that I've created. But what I have to take away to find the area of my triangle GHJ is going to be to subtract the triangle that I formed itself. So if I look at this one right here, this little guy, we said that this was 2.2 and this one was 6.7. And so the area of this triangle is going to be 1/2 times 6.7 times 2.2. And I find that to be 7.37. Okay, so then what I'm going to do is I'm going to subtract this 40.87 minus 7.37, and I find it to be 33.5 centimeters squared. So that's a rough estimate of what our answer can be. And that's actually pretty accurate from what I think it's going to be. If I look at the triangle right here, I think that the area could be very reasonably 33.5 centimeters squared. Now in this lesson, in pre-calculus, we would actually be looking at a side angle side method using the law of sines, law of cosines, that kind of form, to find the area of this triangle. So if we were to look this up, and if you had time and able to look up areas of triangles when it's when you know two sides that are next to each other, adjacent sides, and an angle between them, you'd actually find that there is a formula to find the area, and it's 1/2 base, or excuse me, 1/2 side, side, and then sine of the angle between them. So if we're going to do that for our example, and we can use this to check what we just got, we can see that one of our legs was 10 centimeters, another leg was 7 centimeters, and the angle was 108 between them. So 1/2, one of the legs was 7 centimeters, the other one was 10 centimeters, and then we had sine of 108 degrees in between them. So notice this is taking exactly the numbers for what they give us. Okay? And when I do that, I go to my calculator, 1/2, 7 times 10 times sine of 108, I find it to be 33 point, and rounding to the nearest tenth would be 3 centimeters squared. So in our method that we used before, using methods that we've done before, and if we had no idea on how to start this problem, we found an answer of 33.5 centimeters squared. Now looking back, another way to solve it would be to look at this, and we'd get 33.3 centimeters squared. And so then the question is, okay, so if I have two different answers, how is it that I get two different answers? Or what is it that would lead us to get something so similar, so different? And it all comes down to, right here, these answers that we got. And that would be based upon rounding. And so I rounded both of these to the nearest hundredth before, and to the nearest hundredth. And then when I subtracted, I got something that was to the nearest tenth. And so, so it all comes down to rounding that we would get a different answer. So this actually is a very logical answer to get 33.5, a totally different way of solving it than the algorithm that we did before. Now sometimes the question is, well, why is it that this works? Why wouldn't we use this in a right triangle? Like, let's say this one right here. Why wouldn't we use it? Well, if we did use it, it would go something like this. We'd say 1/2 times one of the legs, which is 2.2, the other leg, 6.7, and then sine of the angle in between, which we know to be 90 degrees. Now, what is sine of 90 degrees? Sine of 90 degrees is just 1. So when I solve this out, 1/2 times 2.2 times 6.7 times 1 is the exact same. So we're actually using this algorithm that we looked up right here for side angle side all of the time when we're finding areas of angles, or excuse me, areas of triangles. When we know two legs, we would know the base and we would know the height, okay, and the angle in between them. And so it works for right triangles. So this is just another way of reiterating how is it that we know this formula and how is it that we can solve these problems.